Hello everyone. So in this video, I'll be discussing the scalar product, which is also known as the dot product. So it is like when two vectors get multiplied. So I'll go with the definition. The scalar product of any two n vectors. N vectors means there are n elements in both the vectors is defined as a dot b. So it is actually a1, a2, an dot b1, b2, bn. So this is nothing but a1 multiplies with b1 plus a2 multiplies with b2, then an with bn. So this is a1 plus b1, a1 b1 plus a2 b2 till an bn. So this is written as summation ai bi. Now suppose if a is this, the vector a is -5, 3, 2 and vector b is 0, 7, -1. So a dot b would become -5 into 0 plus 3 into 7 plus 2 into -1. So this becomes 0 plus 21 minus 2. So a dot b becomes 19. Now suppose the prices are given to you. Suppose we are talking about three commodities. Commodity A, B and C. The price for the commodity, which is the price vector, is 5, 2 and 10. Now there are two individuals, suppose X and Y. X is consuming 10 units of A, 2 units of B and 7 units of C. Similarly, Y is consuming 5 units of A, 1 unit of B and 1 unit of C. Now we are supposed to see what would be the expenditure for X. The total expenditure of X would be the price into the quantity. So this is the total expenditure for X. This would be the price into the quantity. So this would be, we can find with the help of the dot product. Okay, so this would be 5 to 10 dot. So this is the price, corresponding quantity is 10 to 7. Similarly, so we can find this, the total expenditure by X would be 50, 5 into 10 plus 2 into 2, 4 plus 10 into 7, which is 70. The total expenditure is 124. Whereas the total expenditure by Y is P into Y, which is 5 to 10 into 5, 1, 1. So this would be 25 plus 2 plus 10. So this is 37. Now, so the expenditure by both of them, okay. So P into P dot product with X plus Py is equals to P into X plus Y. So we'll see whether the economic interpretation is this: the total expenditure by X and the total expenditure by Y should be equals to the total quantity purchased into the price level. So we have found this: P into X was 124, P into Y was 37. So this total is 161. Now we are, if we are supposed to find, I'll just erase this up. Okay, now suppose for the same given example, we are supposed to find price into the total quantity. So this would be price, the total quantity would become 10 plus 5, 15, 2 plus 1, 3, 7 plus 1, 8. And the price vector was 5 to 10. So this into 15, 3, 8. This becomes 5 into 15, 75 plus 2 into 3, 6 plus 80. So this is coming out to be 81 plus 80, 161. So this is giving us the same result. Now looking at some of the rules for the scalar product. if A, B and C are n vectors, which means there are n elements in it, and alpha is scalar, then A into B, A dot B equals to B dot A. A dot B plus C equals to AB plus AC, that we have already seen in this example, in this specific example. Alpha times AB, alpha A times B equals to A times alpha B, which is the same thing as alpha times AB. And A dot A is greater than 0. So A dot A would be A1 into A till AN multiplied with AN. So this would be A1 square plus A2 square plus AN square. And A dot A can be represented as this, which is A1 square plus A2 square plus AN square under root. Similarly, A minus B, the vector A minus B can be written as A1 minus B1, the first element, A2 minus B2, second element, and till the nth element would be AN minus BN. So the length of the vector would be B into A minus B under root. So this is A1 minus B1 square plus A2 minus B2 square whole square till AN minus BN whole square. So this would be the length of the vector. Now coming to the Cauchy-Schwarz inequality and how do we find the length. So you know, for a 2D figure, we can find the diagonal with the help of the Pythagoras theorem. So if this is x, this is y, so z square becomes x square plus y square. So we can find the value of z according to this. Now in this case, suppose we are supposed to find the distance of the diagonal P and Q, which is denoted in the red. Looking at the initial base, this initial base, I'll mark with yellow, this base. Okay, for this, the diagonal PR, which is marked in red, would be diagonal PR square, because using the same Pythagoras theorem again on this, would be B square plus A square, right? And now, so we have got this, and now looking at this triangle, the covered area in green, this correspondingly this and this. So with the help of this, using the Pythagoras theorem again, we know PQ square, so the diagonal is PQ square, this is equals to PR square plus C square, the height is C. And since we have already found using the Pythagoras theorem itself that PR square equals to this, so PQ square becomes B square plus A square plus C square, or which is the same thing as A square plus B square plus C square. So we have found this. So PQ becomes under root of A square plus B square plus C square. Okay. Now suppose if you're talking about this particular thing. Now we know the sum of the length of the diagonal would be the sum of this thing and this thing, the square of this, then the under root. Now look at this figure, the x-axis is in this direction, positive, so this would take negative values, right? This area would be for the correspond to the y-axis, and this height to the z-axis, and this particular area, I'll mark in red, this area would correspond to the x-axis. So corresponding, since it is a rectangle, it is a cubic figure, so this both the reds are equal, right? So we have here a1 minus b1 mod of this, because the distance is always positive. This is a3 minus b3 given the coordinates of p and q that we have mentioned, and this is a2 minus b2. So with the help of this, the distance was, as we use the Pythagoras theorem, we have observed this. Now with the help of this, we can see the distance is a square. So this was a, I'm marking green. This was a, this was b, this was c. So it is a minus 1 b whole square, a1 minus b1 whole square plus a2 minus b2 whole square plus a3 minus b3 whole square. So since it's square only, it can be written as, so the distance is under root of this according to this formula. Now we have found the same thing. So this is the formula of the distance. Now coming to the Cauchy-Schwarz inequality, I'm not sure whether you are supposed to derive the proof of it or not, since it is highly unlikely that they will ask you the proof for this. So I'm leaving that part. In case if I get to know it is important कि वो paper में भी पूछ सकते हैं, तो I'll upload a video where I'll be solving this as well. ये सिर्फ this is conditional upon अगर ये important है या नहीं. Okay. Now checking for Cauchy-Schwarz inequality when a equals to this, b equals to this. So a dot b would be 1 into minus 3 plus minus 2 into 2 minus 4 plus 3 into 15. 3 into 5 which is 15, and mod of this. This is the left hand side. So this is coming out to be minus 7 plus 15, 8. Whereas length of a is 1 square plus minus 2 square plus 3 square, whereas length of b is minus 3 square plus 2 square plus 5 square. So length of a is 1 plus 4 plus 9 under root 14, and length of b is 9 plus 4 13, 13 plus 25 38. So you can easily see that 8 is strictly less than under root 14 into under root 38. You can use your calculator, you can see this. Okay. And you just need to remember this inequality. This is the most important inequality, you'll see. You just need to remember this. Also it makes sense because if some of the elements of a, suppose if the elements of a are minus 1, 0, 1, whereas the elements of b are 0, 1, 0. In this case, a dot b would be, what would be a dot b in this case? It would be minus 1 into 0 plus 0 into 1 plus 1 into 0, 0. But length of a would be under root 2 and length of b would be under root 1, which is 1 only. So 0 is always less than 1 into under root 2. Okay, so this is not a proof. I'm just giving you an example that it would happen always. Okay, now moving to orthogonality. What does orthogonality means? So two vectors are orthogonal. Firstly, what is orthogonal? When the angle between two vectors a and b is 90 degree. So when angle between two vectors is 90 degree, then these vectors are said to be, suppose this is a, this is b, this is b and a, and if the angle between these two vectors is 90 degree, so these vectors are said to be orthogonal to each other. Which means, so if they are orthogonal, that would mean the dot product for them would be 0. So you need to know if dot product is 0, that means they are orthogonal, and vice versa. If they are orthogonal, that would mean the dot product is 0. Now suppose if I give you a question, now you need to tell me for what value of x, I'll give you a question from the book itself. 3. This is a vector, first vector, and the second vector is, so you need to tell for what value of x are these vectors, suppose this is vector x and y, orthogonal. So we know when the vectors are orthogonal, if x and y are orthogonal, then the dot product or the scalar product would be 0. So x dot y becomes x into x minus 1, 3, x, 3x. So this would be x square plus x into x minus 1 plus 9x. So this should be 0. So this is x square plus x square minus x plus 9x equals to 0. 2x square plus 8x equals to 0. You can take 2x common. X plus 4 equals to 0. So this can be 0 or this can be 0. So for when x equals to 0 and x plus 4 equals to 0, which means x equals to minus 4. So when x equals to 0 and x equals to minus 4, the two vectors would be orthogonal to each other. Okay, thank you.